Hey everyone, good afternoon. Hope you all had an okay or good lunch. Give me a sec, it's not letting me add right here. Trying to let everyone in from the waiting room. There we go. Welcome everyone, welcome. Yeah, good afternoon. Thank you so much. All right, welcome back into AP Calculus. Tomorrow, I don't think we meet tomorrow, but the next time we'll be meeting is Thursday. All right, so it is February 9th. My question for you here today for our attendance check is, how do you express yourself creatively? So, are you a person who writes? Do you draw? Do you, I don't know, there's different things you could do. So, how do you express yourselves? It could be writing, texting. Yeah, there's different ways. It's hard for me to list them all, but how do you express yourself? Or what's the best way? Um, you're able to express yourself. And I'll give you all some time to write in your thoughts on that as I make sure that I'm letting everyone in. All right, we have here some thoughts. Ooh, I like the different things coming up. Wow. Writing stories, that's awesome. Something I didn't know. Wow. Writing, I like to paint and listen to music. Ooh, listening to music. I didn't even think about that. That's a good one. We have drawing. I like to draw and do my makeup. Yeah, that's awesome. Drawing and clothing. Ooh, I like that clothing was brought up. That's true. That's a way of expression. Liking to decorate, the music I listen to. I just talk. Hey, that's cool. Some people are like, their best way to communicate or their best way of expression is just talking. Music, and I like writing sometimes. Doodling and coloring. I'm not creative, lol. I'm not sure. Oh, it's okay. Hey, when I was younger, it's weird. In high school, I used to make cartoons, and I don't know, but I don't do those no more. I used to do little like kind of comic strip cartoons as a way that I would kind of do my little creativity stuff. Now, the best way I like to communicate as an adult, I mean, I prefer through writing. So I like writing as my communication. Talking would probably be my second choice, but writing I think is the best way. I like that some of you brought up music, makeup. I think I could totally jump in on that boat. Music, makeup, clothing as well. Ways to kind of express yourself creatively. I love those. And that's okay if you don't know. Totally okay. All right. Maybe some of you express yourself through math. Just kidding, no. All right, let's see who we're missing. We're missing Kaylin with a C. We're missing Fernanda. We're missing Evie. And I think that's it. So Kaylin with a C, Fernanda, and Evie. If you are actually here, please let us know. Otherwise, let me go ahead and hit submit here. Thanks for sharing, y'all. I also know some of you like, I don't know if I do know some of you do like some digital media stuff as well. It totally counts. All right. Thank you so much for sharing. Let's jump into it. Oh yeah, I forgot. I think slides. I'd be making slides here for classes. All right. So here's our agenda here today. We just had our attendance check. We're going to be doing some Desmos group work with the first derivative test. Feel free to correct that typo if you're already following along on the slides, but group work. And actually, that's a good reminder. So again, remember how we're usually following along as we make a copy of the notes. Though I will say something, because we're mostly going to be doing Desmos, we're not going to be like deeply, like we're not learning a step or a process, nothing new today, if that makes sense. But where you want to go to is Q3, day 5. Our notes are linked there on our Google Classroom, so you could follow along with me so you can see what's up, where we're going, so forth. Yeah, so we're going to try to kind of get some practice with the first derivative test, the best way to do that is through communication with each other. So kind of like asking each other questions, and for those who are kind of like, I almost get it, when you're able to explain it to someone else, it kind of clicks as well. Um, so hoping for that group collaboration there to kind of solidify some understandings with the first derivative test. If I see that groups are getting stuck on the Desmos, right? I could bring groups back and I give feedback, send you guys back. That's usually how it works. I do not know if we're gonna get a chance to talk about concavity today, which is number 4 down here. It's okay if we don't get to it. All right. So asynchronous number 3 was posted. That one is due tonight. I do want to say sorry. I know I was trying to kind of get to updating the grades. Some of you were like, hey, I turned in something. I tried my best. I did not have time. So I'm hoping I could get it in right after class. Right after this class is our office hours though too. So if you want to jump into office hours and make sure I enter a grade, I could do that as well. But I'm planning to catch up on any submissions right after class. So just in case if you're still waiting for your grade to be updated, that's where I'm at in that process. Yeah, let me know. Does anyone have any questions about the agenda or anything like that, or what we're doing today? Let us know. All right, awesome. So before we jump into, groups like straight up, I'm just gonna quickly review with you what we did. Okay, slide number 4, this is review. So yesterday we learned about the first derivative test. We kind of learned a process for it. And the learning goal was I can apply the first derivative test to determine some key features of my function. What are those key features? So the first derivative test not only tells you about maximums and minimums, or we call them maxima and minima, but they also tell you where your graph is decreasing and increasing and so forth. And again, this all comes from the slope of the tangent line. The major part of the rule is if you have a change in sign from positive to negative, so the slope of the derivative changes from positive to negative, then you have a relative maximum. Let's see how that makes sense. Positive to negative, local max. And if the derivative changes from negative to positive, so down to up, you have a local minimum. So that's basically what the first derivative test is. But of course, the first derivative test has a whole process, and you all kind of went into that process in yesterday's Google form exit ticket. So this is me just recapping for us what we did. So you're not writing anything new here. Again, this is just the general, what is the first derivative test? If you were to see it in a textbook or something. But basically what it involves is we have to get our critical numbers, which kind of ties back into the first thing we did in our first days here back in AP Calc. Critical numbers, there's a whole process for that. But you don't stop there, right? Once you have your critical number, you take it and you put it on a sign chart. So that was a new thing here, a sign chart. And you divide that, you use the sign chart to kind of divide up a number line into separate intervals or separate chunks, and you got to test each of those chunks. So that is what the first derivative test tells us. And basically with the sign chart, you can determine whether or not you have a max or a min. You could also determine where your function is increasing or decreasing. So that's just a little recap on that. And just to show you, I'm on slide number 7. So this was the example I showed you yesterday. This was some steps where we had to first find a critical number. And then this is what it looked like when we placed it on a number line. We divided it into 2 separate chunks. This one gave me a negative derivative. That means I took any number to the left of 2 and I chose 0 and I plugged it into the derivative. Super key here. I was getting some questions like, wait, what do I plug it into? So if you go back to the slides, you'll see it says you got to plug it into the derivative. You have to check whether or not the derivative is positive or negative. So I plugged in 0 and I got -4. Because this was negative, that means all numbers, if you were to plug it into the derivative, will give you a negative. And that means my function, the original function, OG function, is decreasing at this interval. Likewise, you would test any number to the right of 2 in this particular example. I chose 3. Notice how 3 is getting plugged into the derivative, not the original. Remember, the derivative is this first one here. So again, that's what we're plugging into because I got some questions on that. Once I plugged it into my derivative, I got a positive 2. Because 2 is a positive number, we can conclude that in this interval, the derivative is going to be positive, aka the original function is increasing. So that's how we're using this here sign chart. And likewise, if you were to kind of sketch this, so it's decreasing, right? That's this part, decreasing. And then once it hits x equals 2, it's going to then increase. So then we can conclude that we have a local minimum at this here critical number. We have a minimum here, and that correlates with the function decreasing from the left of 2, increasing to the right of 2. And I want to give some feedback. So in the Google form yesterday, many of you were on point and you stopped around here. You stopped around finding the critical number. Most of you got to the critical number, but after that, we got people getting stuck, and that's okay. But again, the recommendation, if you get stuck, just go back to the slide and try to attempt like the sign chart. That's what you want to do next. Like, hey, I'm stuck. Next step, go to the slide, try to attempt the slide chart, the sign chart, because that's the next thing that's next when it comes to derivative test. The first derivative test. So let's go ahead and talk about yesterday's Google form. I tried to bug some of you because I still didn't get it, but I'm going to be checking today to see who submitted it. But here what I have for you, slide number 8, y'all, is the common response. So the common response is that, no, not common, about 50% of you got stuck around here. So first off, excellent process. Step 1, they took the derivative. Step 2, they set the derivative equal to 0. That's where they're investigating, the critical number. They solved for x and they obtained a correct critical number. But after that, it was done. We're not done yet, right? We need to test whether or not at this critical number, we have a local maximum or local minimum. You also want to check when your function's increasing or decreasing around this number. Using a sign chart. So that would have been my feedback for the next step on this student. And feel free, this is right now this is your pieces of work. It's anonymous, but feel free if you're okay with your name being known. All right, so here I obtained a sample that finished up the problem. So again, I want to applaud you if you got here. That is awesome. Like, we got our critical number. I think you're amazing for that. We want to now just push a little bit further, and you could take a look here how this student went ahead and took the critical number, placed it on the sign chart, and they tested the left-hand side of -2 by plugging in, they did -3 into their derivative function. Because they got a -2 as an outcome, they concluded that you have a negative derivative here. So that means it's all decreasing. The function is decreasing from the left of -2. And as you can see, they needed to test a number to the right of -2. An easy number that's to the right of -2 is simply 0. That's why they plugged in 0 right here into the derivative function. And it's nice that they labeled derivative right here. And they got a +4. That's where the plus comes from. Therefore, they can conclude that you have you're going to have a minimum at this location. Now, I'm not sure about the point here, -2, 0. How you get the actual point of it is you want to take -2 and plug it into the original. See, that's where people kind of get lost. Like, is it derivative or original that I'm plugging into? I haven't checked that one, but if y'all can check it, feel free. But, oh wait, wait, let's see. They took -2, they plugged into the OG function, and they got -2. So it looks like the minimum would be at -2, -2, but correct me if I'm wrong, if anyone is following along with this. But this student pretty much got it that we have a local minimum at this critical number. And I think according to this student's calculations, the local minimum would be precisely at -2 comma -2 would be where that minimum would be. And y'all can double check that. That's based off the work down here. I love how they put OG function too.
I have a question.
Yeah, go ahead.
How did they get -3 on the left side of like the little
Right here.
yeah.
Okay, perfect. So basically, when you're making a sign chart, right, they plop down right here, down in the middle on a number line, x equals -2. Now, you're dividing this into two separate chunks, numbers to the left of -2 and numbers to the right. Numbers to the left of -2 are -3, -4, -5, you know, continuing more on kind of like you're on a number line. So like the easiest number they chose to test out, the smallest negative number that's to the left of 2 is -3. But that student can feel free to kind of elaborate more if that's, you know, why they chose -3. But -3 would have been right here if you were to draw it on the number line. So kind of like that's the smallest one. You could have, if you want, plugged in -4 or -5. Any number will work. But because -3 is kind of the smallest one that's to the left of -2, I'm assuming that's why they plugged in -3.
So if we did like -4, it would still give us -2.
It will not give us -2. It will give us a negative number. And that's all you need to know to conclude that in that interval,
Oh,
yeah, that's all you need. It wouldn't matter. So you could test any number to the left of -2. You'll see that you're going to get a negative number. And that's why you put a minus right there. Let me kind of erase these. That's why there's a little minus in this box. Awesome. Any other questions? Those are good questions so far. So again, most of us got to the critical number. We just need some support and more work on, you know, using the sign chart and determining what is the local min or local max of the original or OG function. Right here we got OG. All right. Any other questions before we jump? Burning questions, and or if you want to hold on to those questions and wait till you jump into your group, because we're going to continue. We're going to be doing this, so let us know. Otherwise, I'm going to go ahead and move on from this. So again, that would be the correct answer would be there is a local minimum at -2 comma -2. Oh, okay. The 0 was because I was getting confused because they're both -2. That's okay. So that okay, so that was what the original 0 was, just as a way to keep track. Okay, if it was smaller or larger. Yeah, no problem. I think it's good. So I'm hoping that we get deeper into this here today. Let me go ahead and clear this up. If there are no questions on reviewing on that Google form quiz, again, if you haven't done it, you still have time to do it. You even have some access points here to look at. All right. So y'all, we're going to be jumping into the group Desmos using the first derivative test. Our goal is try to apply the big ideas, right? So big ideas is stuff we've been discussing. It's our slides. Also, it's all on the big ideas packet. Again, remember the goal is productively struggle. That means you're going to have questions, you're going to have wonders. That's going to equal true learning. So if everything was easy right now, like, oh, this all makes sense, this is cool, you wouldn't actually be learning because it made sense to you at the beginning. That means it's like, what are you learning new? So so it should feel a little bit like a brain struggle, you know, when you're actually learning something. So that's normal. And again, I'm just mentioning this because you know, there's a lot of steps involved in this, and it's okay to feel that way. Okay, so in a second, give me a sec. I'll put us in our groups, but I need to show you where's the oh, there we go. So actually, if you're following along on the slides, right, and only one person in the group will need to log in. Let me share my screen. Sorry, I just couldn't see this when I was presenting right now. Move this up. So if you go to slide number 9 and you go right here in the notes, in my slide note section, this is where you can click and you automatically get to go inside the Desmos. So that's once you decide who's going to be the screen share, only one person needs to do it. So once you click it, you put your name or all your names and you hit go, and then y'all are going to start as a group together to finish this Desmos. So let me know if anyone needs me to kind of clarify that. But this is once you're in your groups. Again, the link for the Desmos is at the bottom of slide 9. All right, let me go ahead and create the groups. So give me a sec. I know I sent a group feedback thing. Not everyone got to fill it out, so I kind of just basing it off my memory because I lost who we had for the first time around. So I apologize, but let's see. Okay, so yeah, someone's gonna reconnect, so I'll wait. Okay, so not everyone is here, so your group might have, no, actually we got everyone. And some might have 3, some might have 4. So let's make this work. I'm gonna go ahead and open up the rooms. I'll be popping in to make sure everyone could screen share and all of that. All right, everyone, go ahead and join your group. Join your group, join your group.
How are you guys? And who wants to?
I already logged in, so I
Okay.
can just share.
Then what you say?
I can share mine.
Can you hear me?
Oh, there you go.
Okay, I'll share mine. Oh, sorry. You see my background.
Hey everybody, hi group, how's it going?
Good. I think Rose is gonna screen share.
All right, awesome. Oh, Rosa said Israel said he'll do it. Okay.
Yeah, he said that he would.
Okay, awesome. Just make sure you know where to go for the link, Israel. So slide 9 at the bottom of that, you can click on the Desmos. I'll be back. So awesome. Hi group, how's it going? Any technical difficulties or anything? Hi, hey Kaylin. Who's sharing screen here? I went ahead and typed it there in case. Okay, so Kaylin can't. Who can screen share for this group? Okay, you don't know yet? Do y'all want some time to figure it out? I'll just pop back in. I'll pop back in. So remember, for the person who's screen sharing in this group, go to slide 9, and at the bottom of that, click there on the link. It should take you to our Desmos. Let me know if y'all have any questions. I'll be back, y'all.
Go, Sophia.
Yeah, Sophia, facilitate. Lead us into the next generation.
Wait, I didn't agree to this. What's going on?
You didn't not agree to it. Double
Okay.
negative. You did agree to it.
My job.
Okay, just
There's like 8. Alright, Miss Adana, are we all supposed to do it on our own, or do y'all do it together?
Together, yeah. So y'all can just go ahead and do it together. Do your best guess if you're not sure, and that's okay.
Okay, so on just on mine then.
Yeah, and then everyone could just input their thoughts.
Okay, thank you. Okay, do you want to read this?
Okay, so a rising/falling chart lists critical values, derivative sign at.
Hey y'all. Is screen sharing, so was Israel not able to screen share? Who's gonna screen share? It looks like, I don't know if Israel, okay, so he can't. Sorry. Stop my thing. So Israel can't. Who can take over?
I can't either.
Okay, how about Rosa? Are you guys on a computer? How come it doesn't let you screen share? That's interesting. Or are you on the phone? Uh-oh. Okay, so that's a problem if y'all can't screen share. Because then I could probably disperse you into different groups. Okay, we got it. Yay. Thank you, Rosa. Awesome. And y'all can go ahead and decide who's doing what. I don't know if y'all are, yeah, y'all can decide. Awesome. Hey everyone, how's it going? How's that screen sharing stuff going? Okay, so Shannon's trying, but stuff is bugging. All right, any luck with anyone else? I know Kaylin couldn't. Shania, Stormy, how about you two? And then I'm using 2 separate devices. And then I can't, I'm on my phone. So I'm trying to see what we could do to problem solve this then, so that you all can get a start on this. So everyone in this group is unable to screen share. The only way I could problem solve this, guys, is I can move you into different groups because everyone got started on their screen sharing, and we'll just have them add your name, and it's okay if it's more than 4 people. So yeah, I think for our next group time, just we'll see if we're able to get, like, someone could be on, I don't know. We'll try to figure this out so this doesn't happen the next time.
You hear me?
Yeah, I could hear you.
Yo, oh, okay. Oh my gosh. Okay. My computer is like really like, I don't even, okay. My computer's tripping, but I'm getting it back together. Okay. Wait. I'm gonna try.
You think we could?
Yeah, I'm gonna try this. I'm gonna try this one more time.
Okay, that could work, because otherwise the other groups will be too big.
You see?
Yes.
Okay. Yeah, my computer is just being really like mean to me. I don't know.
Okay, we got it. Let's hope it doesn't stay mean or mess with us. Okay, yay. Okay, I'm so glad this group got it.
Because I was trying to speak and everything and even share, but like it wasn't letting me do anything. But okay, I got it. Cool.
Got it. All right. Awesome. I'll be coming back. Y'all can get started there. Yay.
All right, my bad, guys. I was not expecting.
Become
Yeah.
right. 'Cause,
Yeah.
Yeah.
yeah, it's just this is it. So then we set it equal to 0, squad.
Okay.
Sophia, what's the next step, huh? Oh shoot.
Sophia.
Which one?
Whichever one you guys want to answer.
Babe, do you want to go or do you want me to go?
You go.
Okay.
Becomes 2x
Oh, you already did it.
minus 6.
Am I doing it right? Can I just type?
Yeah, you are doing it right.
Oh my god. Okay.
Because then when you get to from the other side.
So we have to do the sign chart too.
Yeah, I'm not really sure how to do the sign chart. I'm like,
Yeah. Where could I even find it on here? Critical points. It's like this thing that she was showing us. Man, I have like no room.
same.
I don't know how I would do
Okay,
it.
so we have to plug in the negative number into the original function, right?
Yeah, like how
Or any
this
number on the
one is
left.
3. So then this one,
Can we do
one of
2?
them would be 0, and then one of them would be like
4.
mm-hmm.
Okay, so 0 squared is 0.
Oh yeah, 4. How are you writing it? Are you writing it on the document too?
I'm writing it on a notebook.
Oh, okay. I should probably rewrite this then.
Mr. Donald said plug it into the derivative. We plug it into the original function, right? Just check back into the big ideas packet.
Ah. Okay, to the derivative function, Edgar says.
So Edgar says derivative. Yeah. So if you went back there, that little sign chart, it says plug it into the derivative. So you all said 4 and 0. Perfect. And then for this, Roxana, you get to go ahead and at the top just put that y'all got x equals 3 and just try to
Okay.
make the sign chart. And that's all.
Yeah, I don't have enough room.
Yeah, no problem. Oh, I didn't know that. Yeah, Edgar, I'm gonna let you in right now.
Sign chart. Oops.
Right, hey Edgar, let me go ahead and stick you in. What group was it called? 1 second. I know your group. It's breakout room 9. Okay. All right. I think you should be assigned now. See if you got an invite. Hey group, how's this part going? Rosa, Israel, James. Okay, it's going good. What's happening in this slide? Like, we're on the graph.
So I think we're about to factor out the equation right now.
I see. Wait, are y'all doing this on a piece of paper or something? Oh, is that what's happening? Okay, and then y'all at the end will just put the conclusions there. That could work. Okay, awesome. I was just curious. All right.
Stormy, did you get the same thing?
What did you get in?
We got Shania and I got 3. Yeah, I said 3. Shania and I got 3.
Yeah, I got it too.
All right. Caitlin, did you also get 3? All right, cool. All right, and then we had to figure out if it's going from negative to positive or vice versa.
into the one you deleted, you erased, and I got -6 for 0, and then for 4 I got 2, which seems correct because 0 is the one on the
Wait,
left of it, and I got a negative
what is
there.
the one? Can you tell me what's equation you plugged it into?
It's f of x equals 2x minus 6.
How did you get that? Oh,
So it's the first derivative.
Yeah. Yeah, the first derivative. We plug it into the first
I
derivative.
think that's what it said here.
And
Oh,
then
and it's just minus
I
6.
think, yeah. So 2 of x minus 6. And then you plug
yeah,
in.
for 0 you would get -6. For 0 you would get -6.
8 minus 6.
And then
Yeah,
for
you
4 you
plug
would
in.
get 2.
When you plug in 4, you get 2, and when you plug in when you plug in 2, you get -2.
But why didn't you plug in 0?
Because Edgar was saying that
You
it was a
plugged in 2?
0.
No, don't. Yeah, I plugged in 0. I got -6.
Negative
yeah.
No,
6?
I did. I said it was 0.
It's -6 for 0.
Yeah, -6 for 0 and -6. And then the 3, we would plug into the original function.
But then 4 doesn't even equal to freaking -6.
What? Yo.
Look, we're basically supposed to be doing like what this person did.
Yeah, that's what I'm doing. That's what we're doing.
Yeah, so basically
But-
we're plugging in this number and this number, but she always kind of said that we had to do 0.
But I'm so confused.
Because you know here it's x
So
minus
-3.
2.
So we're
Yeah,
doing 0
-2.
for the
And you
negative.
see?
But then for the positive, we're doing 4.
Yeah, for the
Yeah.
positive, we're doing 4.
We're doing 4 for the positive and then the
Yeah,
0. No, we're not doing 0.
yeah, 0 for the negative because it's on the left of 3.
Oh, fucking lost.
Okay.
So for 0, you would get -6. Just write down what I'm gonna tell you. Just write it down.
Yeah, -6. I also got that. -6 and -2.
No, and +2 for 4.
Yeah, no, +2, positive.
And that cancels out. Okay. And then you're gonna do over 6. And then 6 divided by 4 is 1.5. Thus we get x equals 4. X equals 1.5.
Oh, okay, I get it.
Yeah. And then the points that I got were 1, -2. I got 1.50 and 2 dash 2. I don't know. It was with the sign chart where I got confused.
Okay, hey guys. Sorry, I'm a little bit confused. What's happening here in this picture?
Because don't you want us to make a sign chart, and then to make a sign chart, we gotta like get like the last point. And when I simplified x squared minus 6x plus 8, I got 4x minus 6.
4x minus
The x value to like make it 0, I got 1.5.
Okay, hold on. Okay, so this first function that's right up here, the 4x minus 6, right?
Yeah.
This is supposed to be the derivative of the original?
Yes.
Okay, so where did the 4 come from?
Because when you multiply, oh shit.
Yeah, you should get a whole number. Yeah, the rest looks great. Just yeah, it was just that little teeny little thing.
Oh, I confused myself.
Perfect, yeah.
Why
Yeah,
didn't any of my team members tell me that? That's crazy.
Because 1.5,
That's wild, yo.
But that's why I was asking you where. Never mind.
No, don't be smart now. Don't act smart. No.
Okay, so we got our critical number. Okay, now what do we do?
So then we make a sign chart, no?
Mhm.
Like, then we choose, like, we can choose 2 and 4.
Yeah, that's where I got the other pointer I was writing down, but because I messed it all up in the beginning, that's what I'm trying to do.
Okay, we got it. So let's go ahead and draw like a little number line. And then in the like middle, you're gonna put your 3 there. All right, does anyone remember what we do from this point now? Well, for the minus and plus, we actually got to test it. We don't know if it's going to be minus and plus yet. So that's the part where we got to actually like plug in and test. So let's see if anyone remembers. But even so, like I think in a second, I'm going to bring all the groups
Put a
back.
number from the left side of 3, and then one from the left side. I mean, from the right side of 3. So
That's
we,
right.
we could put 2 and 4.
You do 2 and 4. Yeah, totally. A number to the left of 3 that's easier though, in my opinion, would be 0. Just because 0 usually, you know, cancels things out. But you could totally do 2 and 4. That's totally cool too. Let's see if the group is cool with that. Okay, here's the thing. So you chose 2 and 4, right? What are you plugging 2 and 4 into? The original or the derivative?
And the derivative.
Awesome. So that's what you're going to check. And whatever your outcome is, okay, awesome. Look, Rosa got negative when she plugged in 0. So we're going to, so for the sign chart, it is going to be a minus there on that side of 3. So that's when we put the minus. And then y'all are going to check out the next point. Awesome, going good. I'm going to soon bring groups back, but don't worry because we're going to be back in our groups and, you know, we're going to continue this in the next class too. All right. Hey y'all, welcome, welcome. I'm just gonna wait for everyone to come back to us. We could talk about some of this. We only have like one group back right now. I think some groups are busy in their stuff. It looks like people got around halfway and there's one group that kind of is on slide 8. Hey everyone, I think we got mostly everyone back here. Welcome, welcome. Welcome back to our main room. First off, y'all, great job. I was coming into some rooms, there were some arguments, disagreements. That's awesome. That's productive struggle right there. Y'all are trying to understand something and it could get pretty rough. So awesome. It looks, as you can see here, it looks most groups got halfway in. Well, one group is like slide 8, but yeah, just so you know, I anonymized the names so I could give feedback. Of course, I'm keeping track of, you know, groups so that y'all can get your credit. So just some feedback here. Take a look here. What the X's means it's incorrect. So I think 1, 2. Around half of you got, around half of the groups got number 2 incorrect. So slide 2, let's talk about that. Even though it doesn't appear like that's here when I look at the choices. So we look here, so it says f, or the original function, has a relative max at x equals 1/2. So x equals 1/2 is right here. And I agree because if you see that it's going from plus to minus, that means it's increasing. The original function is increasing, then decreasing at this location. So therefore, I agree. This does indeed have a relative max, or relative maximum, local maximum, however you want to refer to it. And that's how we're using the sign chart. We're trying to see if we have local max, local min. We're also trying to see how our original function is increasing, decreasing. One group says that there was a relative max at 4. So if you look at around 4, so let me just erase this. And again, we're going to continue this in our next round. So if you look around 4, right? The function is decreasing, then increasing. So instead of being a maximum here, this is actually a minimum. So we actually do not have a maximum at x equals 4. And this is according to our sign chart. We actually have a minimum. And 3 groups got this one correct, where f is increasing from the interval from -infinity to 1/2. So that's true. The reasoning for that is because, and I'll check out the chat in a second. So from 1/2 to -infinity is that way. So from this interval, -infinity to 1/2. See how it's plus plus? That means our function is increasing from -infinity to 1/2. True. Okay. So those are the two true statements. Let me know if anyone has questions though about this slide here. So again, the only incorrect one was that this was a max. Everyone should agree with this last one as well. I think it marked it wrong if that last one wasn't marked. Oh, sorry. Let me check the chat. Oh, okay. That's just for a group thing. Okay, so yes, please make sure you make your corrections there if this is perfectly clear. Now we're going to be continuing this in our next round, right? Next class, because most of us are only halfway there. As for feedback, most of you have gotten the critical point and are on the process of testing your critical point. So we're going to go ahead and talk a little bit about this, but just in preparation for our next time. It's going to get into a more complex version of it. So again, productive struggle, just be ready to put on your thinking hat for our next time. But otherwise, I think we're at a good place, y'all. All right, I don't think we have time for a checkout. So y'all have a great afternoon. See you later. Again, I'll try to input the grades. I do have office hours if you want to stay here today. If not, you're free to go. Bye, everyone. Great job. I loved all the productive arguing and all that. Bye, everyone.
I have a question.
Hey, James, what's up?
Hi, how are you?
How are you? Yeah.
Pretty good. So I submitted the test really late.
Yeah.
It was like 11, but I just had something to do, but I ended up finishing it. But the second one was kind of confusing. But do you know if you can check it right now, just to see if it makes sense to you?
Yeah. And I still haven't inputted it. Like I seen your remind text. The day was like really busy. So let me get to it. Hold on. So it was first derivative test. Oops. Just search it. There you go. Okay, good. I still have to input everyone who did this. So, all right. So you're saying the second part, number 2?
Yeah, and the first one. I don't know if the first side does make sense to you.
Yeah, it's perfect. So the graph first decreases then increases. So that's the same thing as the slope of the derivative being negative and then positive. And then relative minimum, same thing. That makes perfect sense. Yeah. And then this one, I mean, in today's slide, you saw the correct answer, right?
Yeah. I think I did. Oh, it was like -2, I think.
Was it? Let's see.
Or 2.
Because see if like even if you set it up right here, right, you would have to -2 both sides. So x would be -2 right here.
Oh yeah, I think I just missed the negative. I was doing the math in my head and then I missed the negative part.
Right. So that's the first one. So yeah, you just want to fix your critical point. I mean, otherwise this conclusion would have been true though. No relative. It would look something like that. I mean, there are cases where it does do this. But in this case, this one did have, I think it was a minimum. I forget, or max, I don't remember. But it's on our, if we go back to slide number 8.
So it ended up having a relative minimum.
That one had a minimum. That's correct. And I'm looking at slide 8 here. I posted the answer to it, right?
I think it was just because I forgot the little negative sign, right?
Yeah, and then after that, whoops, and then after that, like a lot of students, where's the picture? There we go. A lot of students, no, you went to the sign chart, so you're good. No, that's perfect. It was just the -2. That's right.
Yeah, I think that's the only part I just accidentally missed. That made my answer look confusing because I was like, we didn't do these yet. So I was like, oh, but I think it was just like something just to get us prepared.
Yeah.
But then, yeah.
Okay, go ahead. My bad.
But then I was just watching a Khan Academy video, and it tells me like the sign chart, if it has a positive is just gonna be a no relative minimum or maximum because it doesn't exist.
Yeah, that's good. That means that you're kind of using that resource because that would have been like the correct conclusion if your number was correct. But yeah. Perfect.
And I did my annotations or the questions for the async 2 yesterday as well.
Okay.
And then I finished async 3 yesterday as well.
Okay, perfect. I'll go.
I just kind of got confused on the notes, but I got all my notes and then the answers to the Khan Academy questions. But I did it though.
Yeah, Khan Academy, sometimes the notes can be a little bit, it's kind of like college level the way he does it or explains things, but you got your exposure to it. That's okay. Yeah, awesome. Okay. I'll make sure to input your grades right now. I guess I'll do that since I don't have that much people in office hours right now. So I'll do that. And yeah, let me know if you have any questions. How about in today's Desmos? How's that going?
Pretty good. I finished from yesterday's async 3. I finished it, so
Perfect.
just like I said, it was just like kind of confusing because he would skip some parts or simple it in like very in complex ways. He would simplify his answers in complex ways.
Right.
But then I understood what he was telling me.
Okay, that makes sense. And your group is
Rosa and Israel.
Oh yeah, y'all were on this part, right?
Yep.
Okay, how's this part going? Is this
pretty good? We figured it out that there was gonna be a relative minimum,
right?
And then that's where we stopped.
Awesome. So then in the next one, y'all jump back in. You'll try to draw what the original function looks like and annotate it. And then after that will be like the one. Probably is that what you saw in Khan Academy? Like
it was something like that, yeah.
It's when it get like if you have more critical points, then it gets bigger, more complex. But it is something y'all could try to like figure out for sure.
And then we don't have your class till Thursday, right?
That's right, till Thursday. So I guess we'll try this out on Thursday.
And then next week we have a whole week off, right?
That's right. Yay, whole week off. Great.
Okay.
We all need that.
Okay. Oh. All right, then, Mr. Down. Thank you.
All right. Thank you so much.
Bye.
Grading. Bye.